Now, let's take OOP a step further by exploring inheritance. This concept not only makes your code more flexible, but also helps avoid repetition, leading to cleaner and more maintainable programs. By the end of this video, you will understand what inheritance is and how it works in Kotlin, how to override methods and properties, the difference between abstract classes and interface. Let's get started. So let's see the basics of inheritance, building on existing classes. In object-oriented programming, inheritance allows you to create a new class that's based on existing class. Instead of starting from scratch, you can reuse the functionalities of a parent class, also called superclass, and add new features or override existing one. For example, let's start with the phone class we introduced in the earlier episode. So you can check it out in the description. So the phone class looks something like this. We have our primary constructor, which holds two properties, and then a function for making call. In this code, the phone class has properties like brand, battery life, and a method make call. Notice the open keyword before the class declaration. This makes the class inheritable. By default, classes in Kotlin are finite, meaning they can't be extended unless you mark them as open. So if you want to inherit a class, you have to mark it with the keyword open. So that keyword open makes that class inheritable. It becomes the parent or the superclass that can be extended or inherited by another class. Now let's create two specific types of phones: smartphone and then feature phone. That's what we call YAM in Ghana, the YAM phone that inherits from the phone class. Here, both smartphone and feature phone inherit properties and methods from the phone class. They can make calls like any other phone, but they can also introduce their own unique behavior. A smartphone can install apps, while a feature phone can send text messages. So to extend from the parent class, we use the colon operator. So this is the parent class, and then after declaring or specifying the parameters for the primary constructor for the parent class, you use the colon after the bracket and then the name of your child class. Here, both smartphone and feature phone inherit properties and methods from the phone class. They can make calls like any other phone, but they also have introduced their own unique behaviors. A smartphone can install apps, while a feature phone can send text messages. So we use this column between the parent class and then the child class. This is how we inherit. So you declare your child class like the way you usually declare classes, but after the declaration and before the opening close curly bracket, you bring the column after the column, then the name of the parent class. If the parent class requires a property, you have to pass those property as parameters to the parent. So if you look at the phone class over here, the phone class requires, anytime you create the phone class, you're required to pass these properties when you are instantiating it. So as you inherit it, you have to supply those values. That's why the child class has declared those values and then passing it to the parent. Let's look at overriding methods and properties. Sometimes you want to override methods or properties from a parent class to provide a different behavior in the subclass. For example, a smartphone might handle calls differently from feature phone. Here's how you can override the make call method in the smartphone class. In this case, the smartphone overrides the make call method to simulate voice over internet call instead of regular one. The override keyword ensures that the method in the subclass replaces the one from the parent class. Let's look at another concept in object-oriented programming called abstract classes and interfaces, defining more flexible systems. Sometimes you want to define a class that cannot be instantiated directly but serve as a blueprint for other classes. This is where abstract classes come into play. An abstract class can have abstract method that must be implemented by its subclasses, as well as concrete method that provide default implementation. Here is an abstract class called device. The device class can't be instantiated directly. It has an abstract power on method, which subclasses need to implement, and a concrete info method, which they inherit as is. Let's extend device with a tablet class. Here, tablet implements the power on method, providing its own specific behavior when the device is powered on. So let's look at interfaces, a contract for classes. In Kotlin, you can use interface to define a contract that a class must follow without enforcing inheritance. Interfaces can define both properties and methods, but they don't provide implementation for them except for default method. Here's an example of interface chargeable. So you use the interface keyword, then the name of your interface. Then you define the function that has to be implemented by the class that will inherit it. Now let's make the smartphone class implement this interface. By implementing the chargeable interface, the smartphone class now has to provide an implementation of the charge method. So to extend from a class and an interface, you use the comma to separate the two classes. And then now the smartphone provide the actual implementation. So these ones only provide the signature of the function without any implementation. So whoever implements this interface will provide the actual implementation. I hope this concept helps you understand OOP better and improve on your Kotlin programming skill. These topics are very important when we jump into our Android development session. You really need it, and you really need to understand the basics in order to follow along when we start the Android basics. If you enjoyed this video, don't forget to like, subscribe, and hit the notification button to stay updated future episodes. Thanks for watching. See you in the next video.